Hi, uh, in this video we are going to study how to calculate the mean. Um, like before talking about the method, let's consider a simple example. Think about a lottery with this probability. So if you buy a lottery, it gives you $0 with 99%, but you may get $100 with 1%, right? Then what is the expected price of this lottery? Is it $50? Because 50 is the middle of $0 and 0 and 100. Of course, no. The answer is no. So it's either 0 or 100. So if you think the average is 50%, you know something is wrong. So this is a quite common mistake. This example is too simple. So you may think you would not be confused in the future, but I see many students who are confused at this point. So even if there are two possible outcomes, the average is not just the average of the outcomes. What you have to consider is the probability. So because 0 is much more likely than $100, so when you calculate the average, you have to put more weights on 0. So expected value should be closer to 0 than to 100, right? Because the probabilities are 99 to 1. They are unbalanced, very much unbalanced. So $50 is wrong. And here I declare one principle. The mean is the sum of probability weighted outcomes. This is the definition, simple one sentence definition. Sum of probability weighted outcomes, not just outcomes, but probability weighted. So let's think about how we apply this. By the way, you know how to calculate mean. So you know how to do that, but still I see many students confused. So let's clear out this confusion here. The reason why you are confused, many students are confused at this point, is because they don't understand they don't have the distinction between different presentations of data. So in the previous chapters and in this slide, there are you saw two different ways to represent the data. First is to list all the outcomes, all the observations. Just list all the outcomes realized, and that is the raw data. Raw data is a bunch of numbers. There is no summary. It's not summarized at all. It is just pure original data, like an Excel file. If you process the data, raw data, then you are going to get a frequency distribution table or probability distribution table. That is a summary, the first step summary. So like this. So these numbers are the same numbers we considered earlier in the previous video. So you summarize 10 grades, 10 numbers into frequency distribution table. So how many A, how many A minus, how many P plus, that. And these are different ways to present data. And depending on what information you have to use different methods calculating mean. That's what we are going to study in this video. So there are two different methods for different forms of data. So first, let's think about the first method for raw data. The raw data can be denoted as x1, x2, xn, and they are just n observations, n numbers. There is no summary, it's just pure raw data. And the mean is the sum of, remember, this is definition, mean is the sum of probability weighted outcomes. Then, like, all the other parts are obvious, but what is probability weighted here? Probability weighted, but in this raw data there is no probability. But what you have to what you have to think about here is that all these outcomes are equally likely. So you have n observations, and when you have n observations without any other context, they should be equally treated, right? Each observation is equally likely. So because there are n observations, single observation receives a weight of 1 over n. So if there are 100 observations, you assume that each outcome has 1% probability, right? Then mathematically speaking, x1 is weighted by its probability, which is 1 over n, right? So 1 over n is probability for n observations, So x1's probability is 1 over n, x2's probability is 1 over n, and xn's probability is 1 over n. All observations get the same weight. And then you can factor out the denominator n, so you may write it as summation of xi, where I runs from 1 to n and divided by n. So this is the definition of how you calculate mean when you have raw data, when you have n observations. Easy. This is the way you calculate average. There is no problem. That is a correct way. For example, if you use these numbers, you have 10 numbers. What you can do here is you don't need to put 1 over n on each number. Simply sum all the observations, sum these numbers, which is 34.7, and divide this number, this sum, by the sample size. Count how many numbers you have. There are 10 numbers, so you get the average. The average is 3.47. 3.47 is the average, the GPA, average grade of student 1. So this is the way you calculate average when you have raw data. So and like everyone knows this. Now let's compare that method with this one. Now the definition is the same. The mean is the sum of probability weighted outcomes. Sorry for this typo, like should be lowercase, not a problem. And to think about this, suppose that there are possible outcomes. The possible outcomes are lowercase x1, lowercase x2, There can be many possible outcomes. And you have to find their probabilities. Probabilities must be given from the probability distribution table. So they are known. You have them. So probability for the first outcome is probability of lowercase x1, probability of lowercase x2. Then probability weighted outcomes are simply multiplication. Lowercase x1 times probability of lowercase x1 is the probability weighted outcome for the first outcome. And there may be many more outcomes. So it's mathematically you can write it this way. So this is one probability weighted outcome, and this is another probability weighted outcome, and you can continue till as many as the possible outcomes. So using the summation notation, you may put it this way. And it's easier to understand when you see a numerical example. In our example, we don't have the probability distribution table in the at first. So instead we have the first step summary was frequency distribution table. And from this frequency distribution table, you can calculate probability, right? Because there are 10 observations. If A minus realizes 4 times out of 10, automatically probability is 0.4. And it's easy. Just divide the frequency by the sample size, which is 10 in this example. And then you have probability. This is what we need to calculate the average. And next, I'm going to make another column. And in this column, you have to multiply outcome to probability. So it is probability weighted outcome. So 4.0, the outcome 4.0 receives a weight of 0.1. So multiply them, and then the weighted outcome is 0.4. And 3.7 happens much more than 4.0, so it receives a weight of 0.4. So when you multiply, the weighted outcome is larger than A. So the weighted outcome becomes 1.48, which is larger than A flat. In that way, but simply multiply 3.3 to 0.3, you get 0.99. 3.0 to 0.2, you get 0.6. And 2.7 to 0, automatically 0. So for each outcome, put probability weights on them, and you get as many weighted outcomes as the original outcomes, right? So then finally, in the final step, you have to add the weighted outcomes. So these are, remember, these are probability weighted outcomes, and the definition of mean was the sum of probability weighted outcomes. So sum, add all these numbers. 3.47. That is the mean. That is the average, right? So exactly this is the same number. This is the same number we calculated from this data. Because both are the same data, just we have different starting point. In the first method, we do not make a frequency distribution table or probability distribution table. Directly use the raw data and get the average. But in the second in the second method, I showed you like when you have first we calculate the frequency and then probability, and then compute the probability weighted outcomes, and finally sum them. It's just a detour. At this point, it is a detour, but in the end, it will get to the same number, of course, the same data. But this is useful because in some cases, if you don't have the raw data, but you only have frequency distribution table or the probability distribution table, you have to use the second method, right? In the homework, in the assignment, if I give you a probability distribution table, you should be able to calculate the mean. You should follow these steps. And finally, one remark. And here, in the first chapter, I defined population and sample in this way. Population can be thought of as the case in which you repeat the experiment for an infinite number of times. But the sample is for a finite number of experiments. So population is purely imaginary and just theoretical object, but it's useful to think about because that is the truth. The true probability of your true expected value. So what is the expected value of a lottery? You have to do it infinite times. So that is the true value. So the population mean is the true mean, but when you calculate the population mean, you cannot use method 1 because the raw data will go infinitely, so you cannot sum them. So there will be infinite number of observations, so you cannot have that data, that type. excuse me, that kind of data does not exist. So method 1 is not used to calculate the population mean. And the population mean is usually denoted as mu, which is a Greek letter. Greek letter mu usually denotes the population mean. Meanwhile, the sample mean is based on finite sample, finite observations. So you may use method 1. Method 1, the example that I showed you, was exactly sample mean. And method 2, which is based on the probability distribution table, can be used in the same way. The major difference here is, so the population mean is the sum of probability weighted outcomes, but the probability there is the true probability. But now in the sample mean is the sum of probability weighted outcomes, but the probabilities are sample probabilities. That's the difference. Sample probabilities are the probabilities calculated from finite observations. So exactly what I have shown you with 10 observations is the sample mean, is how we calculate the sample mean. And sample mean is usually denoted as x bar. So when you put bar, flat bar, on top of a random variable, usually it denotes the sample, the sample mean of the random variable. Okay, so I'm going to stop this video here. Thank you for watching the video, and please don't forget, by the way, the due date of the first assignment is this weekend in 3 days. So please don't forget, and that is the exam. There is no other exams. So the assignment is the exam. So please don't forget. See you in the next video.